Hello guys, welcome to Solving Solutions, your number one channel where you get solutions to all your solving problems. It's 9 having you in class again today. How have you been? We are going to look at something on computational, let's say mathematical computations, right? Good. It actually has applications in adjustment computation. We are going to look at a system of equations with four unknowns. As you can see, we have a system of equations with four unknowns, and then we are trying to determine the values of these unknowns, right? Good. So they say solve the following system of equations using adjoint method. We have these are the four equations with the four unknowns, right? Good. Now the first thing we are going to do. So thanks for coming to class. If you're coming to the channel for the first time, you can encourage us by subscribing. And if you're a returning viewer, thanks for always checking up on us. The first thing we are going to do is to have a matrix notation of our system of equation. So when you look at equation 1, we have a plus 2b plus 3c plus d equals to 2, right? Good. So if we are going to have a matrix notation, which means we are going to extract the coefficients of each of the unknowns, right? Good. So the coefficients of each of the unknowns will now form our A matrix. Are we together? So you know that the coefficient of A is actually 1. The coefficient of B here in equation 1 is 2. The coefficient of C in equation 1 is 3. The coefficient of D is what? Is 1, right? Good. Then we now also have the matrix of the unknown, which is what? The X, right? Good. Then we have our constants, which are on the right hand side, also in a particular matrix. So we now have A multiplying X to give you what? B. That's this, right? A multiplying X to give you B. Therefore, for you to now have X, which is actually the matrix of our unknown, is actually what? The inverse of A multiplied by B, right? Good. So these are important notations, or important expressions rather. These are important expressions you need to note as we proceed in the computation. Now, the next thing is for us to what? Is to get the determinant of our A matrix. Now, if you look at our A matrix is actually what? A 4 by 4 matrix. And it's unlike our normal 2 by 2 matrix or maybe 3 by 3 matrix that, okay, running through determinant is a bit simpler and shorter, right? Good. Now, the A matrix, which is a 4 by 4 matrix, requires a little bit of patience and let's say technicality, right? Good. Now, we have the matrices written out, or we have the matrix, we have the matrix written out, and the elements are in it. And when you want to perform any operation in a matrix, you have the signs alternating, right? Good. So we have plus, minus, plus, minus. That's why you can see what the plus, minus, plus, minus. So if we have up to 5, the next line will be plus, right? Good. So if it were just a 2 by 2 matrix, it will just be what? Plus, minus. And if it was a 3 by 3, it will be what? Plus, minus, plus, right? The alternating signs just go across the row and then down the column, right? Good. So if this is plus, this is minus, this is plus, and this is also minus. So that's how the signs change, right? Good. Now, since we have been able to achieve that, we also remember that when you are trying to perform any operation in a matrix, any element you pick, you are going to exclude that particular row and also exclude that particular column, right? Good. Which means if you pick one, which you've seen here, we aren't doing anything with these other numbers on this row, and we are not doing anything with these other numbers on this column. Therefore, we now have a second matrix after we have selected one, because that's actually the first number, right? So we now have a second matrix of 3, 3, 2, 4, 3, 3, and 1, 1, 1. Please just pay attention. It's very, very simple, and you're going to get it, right? Good. So that's why we have extracted it out. You can see that we have selected one, which is this outside. However, I haven't selected the one. We still have a 3 by 3 matrix, which is not still it's a bit simpler anyway to manipulate, unlike the 2 by 2 matrix that it's very straightforward, right? Good. And it's now better than the 4 by 4 matrix that is a bit gigantic. So we now have what? Our 1, which is the element we have picked out, is the A11. Then we now have those other we now form the matrix that is left. So we have 3, 3, 2, 4, 3, 3, and 1, 1, 1. Now we have a 3 by 3 matrix, and for you to determine or for you to compute the determinant, or for you to determine the determinant of a 3 by 3 matrix, also remember that you still need to pick one of the elements, which is still your A11. Then you cross out everything you have on that row, and you also cross out everything you have on that column, which we have done. And you don't forget the alternating signs, right? Good. So we still have what? Plus, minus, plus for our new set of matrix, right? Good. So we don't forget to also have your alternating sign. So when you now have what? 3, you now know that you've crossed out this whole row and you've also crossed out this whole column. So you are now having what? 3, 3, 1, 1. So that's this particular matrix. So we now have 3, which is the element we've picked out. We have what? 3, 3, 1, 1. Now we come to the next element, which is what? 3 as well. However, because of the alternating sign, the sign before 3 is what? 3 is minus, rather. The sign before 3 is what? Minus. That's why you can see minus 3 here. This 3 is actually the 3, this other 3 here. Then the minus here is what? This minus. So when we use this 3 now, which means we are eliminating everything we have on this second line and also on this what? On this first line, right? Good. So we now have what? 4, 1, 3, 1. That's what you can see here. 4, 1, 3, 1. Are we together? Good. Now coming down to this next or the last element on our row 1, that's row 1 column 3, right? Good. So coming down to this next element on our row 1, we have what? We are going to eliminate everything we have on this row, and we are still eliminating everything we have on this column. Therefore, we have what? 4, 3, 1, 1, which is what? 4, 3, 1, 1. So you now see that simplifying it up to these smaller 2 by 2 matrices, it's now very easy for us to manipulate, right? Good. Now let's proceed. So how do you go about the determinant process? This is what? This multiplied by this minus this multiplied by this, right? Good. So you're coming from left to right minus what? Right to left. That's the order, right? Good. This multiplied by this minus this multiplied by this. So 3 times 1 is 3, right? Good. Minus 3 times 1 is 3, which is what? 0. So 3 minus 3 will give you 0. Then you have this 3 multiplying 0. Then you come to the next matrix. You have what? Minus 3 already outside, which is this. Then 4 minus 1 is what? 4 multiplied by 1 rather is 4, right? Good. Then minus 3 multiplied by 1 is what? 3. So 4 minus 3 is actually what? 1. That's this one you can see here, right? Good. Then you come to the final element, which is 2. That's the 2 you can see here. 4 times 1 is what? 4. Minus 3 times 1 is what? 3. So 4 minus 3 will give you what? 1, right? Good. So by the time you simplify through, you see that what? 3 times 0 will give you 0. Minus 3 times 1 will give you what? Minus 3. Then 2 times 1 will give you 2. So simplifying further, you have what? 0 minus 3 plus 2, which is equal to what? Minus 1, right? Good. So minus 1 is the final answer for this particular element if we are trying to pick this particular element, which is what? A11. Remember, we are still on this A11, not actually the determinant yet. That's why I had to include it here that for A11 we are multiplying it by what? By minus 1. Then we come down to A12, right? Good. Still row 1 but column 2 this time around, right? Good. So for minus 2 we have picked out minus 2, which means the whole of this row will be eliminated, and then the whole of this column will still be eliminated, right? Good. So we are now having what? 1, 2, 1, which is 1, 2, 1. We are having 3, 3, 1, which is what? 3, 3, 1. And then we are having what? 2, 3, 1, which is what? This 2, 3, 1. Are we together? And you can see that this 3, 4, 1 is eliminated because it's under 2. And then you can also see that this 1, 2, 3, 1 is also eliminated, right? Good. So having established our 3 by 3 matrix that corresponds with this minus 2, and remember that it's minus 2 now because of what? The alternating signs, right? We pay attention to the signs. So we have our 3 by 3 matrix. Now we are still going to simplify this 3 by 3 matrix as we have explained earlier, right? Good. So we still pick out the first element, which is what? A11 of that 3 by 3 matrix. If we do that, we are having what? 3, 3, 1, 1, which is what? 3, 3, 1, 1, right? Good. Now the signs are still alternating, so we have minus 3 instead of just 3. So that's this minus 3 you can see here, right? Good. So we have what? 2, 1, 3, 1. Because the whole of this row will be eliminated, and then the whole of this column will also be eliminated. So you'll be left with what? 2, 1 and what? 3, 1, which is what? 2, 1 and 3, 1, right? Good. Then you come to the next element, which is 2. Then the sign in front of it is positive. That's why you can see positive 2 here, right? Good. So this column is eliminated normally, then this row is also what? Eliminated. So you are left with what? 2, 3, 1, 1. So that is what? 2 by 2 matrix. Are we together? Please, if you find it difficult at any point, you can always pause and rewind, because it's very simple for you to understand, right? Good. Now let's proceed. Remember the drill. You come down from left to right minus, you go down from what, from right to left, right? Good. So that's 3 multiplied by 1 minus 3 multiplied by 1, right? Good. So 3 times 1 is 3 minus 3 times 1 is 3. So 3 minus 3 will give you 0. So you have what, 1 multiplied by 0 at this point, right? Good. Now you come down to this next 3, which is this 3, and then it's minus because of the alternating signs, right? Good. So we have what, minus 3. Then 2 times 1 is 2 minus 3 times 1, which is 3. So 2 minus 3 will give you what, minus 1, right? Good. Then you come down to this last one, which is 2. So we have what, 2 times 1 minus 3 times 1. So 2 times 1 is still 2. Then minus 3 times 1. So 3 times 1 is 3. So 2 minus 3 will give you still what, minus 1, right? Good. Now let's simplify for that. 0 multiplied by 1 will give you 0. Minus 3 times minus 1 will give you plus 3. Then plus 2 times minus 1 will give you what, minus 2, right? Good. So by the time you simplify this further, 0 plus 3 minus 2, you get what, you get plus 1, right? Good. So for this second element, we have what, minus 2 into plus 1. That's why you see that in this smaller box. So we said now repeat the simplification process for the rest. Therefore, the determinant, if done correctly, should be, by the time you repeat, so you come down to this third element, you eliminate the whole of this column, you eliminate the whole of this row. So you have your own 3 by 3 matrix of what, 1, 3, 2, 2, 4, 3, and then 1, 1, 1, right? Good. So you repeat the extraction process or the simplification process of getting a 2 by 2 matrix, and you would get a final answer. You come down to this last one, which is what, this should be A14, right? Good. A14, right? Because we are still on row 1 but on column 4, if I'm not making a mistake. So you have what, this whole column eliminated, and then this whole row is still eliminated. So you have a 3 by 3 matrix of what, 1, 3, 3, 2, 4, 3, and 1, 1, 1, right? Good. So you now do everything we have done in these 2 examples. So if they are done correctly, your elements, or let's say the results, should be what, 1 into minus 1, which is for the first one, then minus 2 into 1, which is for the second one, you can see here. Then if you've actually done it well, you should be having what, 3, which is this, into 0. So the determinant you're going to get from your third matrix is supposed to be what, is supposed to be 0, right? Good. Then minus 1, which is this, minus 1. Then the determinant you're going to get here should be what, minus 2. So further simplification shows that 1 times minus 1 will give you minus 1. Minus 2 times 1 will give you minus 2. 3 times 0 will give you 0. Then minus 1 times minus 2 will give you what, 2, right? Good. So you now have minus 1 minus 2 plus 0 what, plus 2. So that will give you minus 1. This now implies that the determinant of our matrix A, which is the matrix of the coefficients of the unknown, is actually what, minus 1. Are we together? It's a 4 by 4 matrix. That's why the explanation was a bit long, but it's actually worthwhile. So if you follow it through, you are good to go. Furthermore, we need to get the cofactors, the cofactors of matrix A. So we need to get the cofactor matrix from A. Now the cofactor matrix is actually similar to how we've actually determined or designed our determinant for each of the elements of our matrix. However, in this case, we are going to do it for all of the elements. So we are having what, 16 elements. Therefore, we are going to have 16 matrices. So we are having we are going to have 16. We are going to have 16 elements in this our matrix. Remember, this is actually a smaller matrix in our gigantic cofactor matrix, right? If you look closely, there's a line here showing that this is a matrix. But we've actually included this in a matrix notation just to show that we are representing each element. Are we together? We are representing each element by each of these matrices. So we are having a single matrix here. Please, that's very important, right? Good. So furthermore, we need to get the cofactor matrix from A. So we come down to element A11, right? Good. Now element A11 would be plus. That's why you can see plus here. So when the whole of this column is the whole of this row is eliminated and the whole of this column is also eliminated, you are left with what, 332. That's what you can see here. 433. That's what you can see here. Then 111. That's what you can also see here, right? Good. So this is the cofactor for the element what A11, right? Good. You come to element A12. Remember the sign here, the sign is minus, right? Good. Now another thing to note is that we are not multiplying it with the elements of the matrix. We are not multiplying the cofactors we have expressed or extracted rather. We are not multiplying the cofactors we have extracted with the elements, right, by A11 or A12, unlike when we are doing the determinant. So that's another thing to pay attention to. While you are performing the determinant or trying to get the determinant, you multiply it by the elements like A11, A12, and the rest of them, right? Good. But in this case, you are just extracting them. You are using the element as a key and then extracting the corresponding cofactors, right? Good. So the next one is what? This minus, and that means the whole of this column is eliminated and our row 1 remains what? Eliminated, right? Good. So we have what? 1, 3, 2. That's what you can see here. Then we have 2, 3, 3. That's what you can see here. Please pay attention. Then we have what? 1, 1, 1. That's what you can see here, right? Good. We come down to our third element, which is what? A13, right? Good. So we pick this, and the whole of this row is eliminated. Sorry, this column is eliminated, and then our row 1 remains what? Eliminated, right? So we have what? 1, 3, 2. That's what you can see. 1, 3, 2. We have what? 2, 4, 3. You can see 2, 4, 3. Then we have 1, 1, 1. You can see what? 1, 1, 1, right? Good. Now let's come to the last element on our first row. So that's A14, right? Good. So we have what? A14. Now the sign is alternating, remember, so we are now having what? A negative sign. Plus, minus, right? Good. So if we eliminate the whole of this column and this row 1 still remains eliminated, so we're having what? 1, 3, 3, which is what you can see here. Then we have what? 2, 4, 3, which is the second row. Then we have 1, 1, 1, which is what? The third row, right? Good. So these are the cofactors that we can extract from what? From our first row. Now we are going to do that for the second row similarly, and you have to pay attention. It's very simple. So coming down, the sign is now alternating. Remember that you have plus, so this will be minus, right? Good. So we have what? Minus here, and then we are having this should be A21 because that's row 2 column 1, right? So A21. So the cofactor, which means this our column 1 remains eliminated, and then our row 2 also will be what? Eliminated. So we're having what? 2, 3, 1. You can see 2, 3, 1. Then for the next line, which is this should be what? A22, right? Good. So on this A22, this second column is eliminated, then the second row remains what? Eliminated, right? Good. So you have 1, 3, 1. You can see 1, 3, 1, and remember that the sign here is positive because this is negative, so this will be positive, right? Good. So we have 1, 3, 1. Then we have what? The next thing to be 2, 3, 3, which is what? This 2, 3, 3. Then the last row is what? 1, 1, 1, which is what? 1, 1, 1. Then we come down to the next element, which is what? A23, right? Good. So which is 3. However, we are not looking at those values. We are just looking at the sign. So the sign here is what? Negative, right? Good. That's why you can see negative here. So if this is negative, the whole of this row is gone. The whole of this column is gone, right? So we have what? 1, 2, 1, because this is the element we are looking at. So we have 1, 2, 1. Then we have what? 2, 4, 3, which is what? 2, 4, 3. Then we also have what? 1, 1, 1, which is what? 1, 1, 1. Remember, this is the element we are looking at, so we don't have anything to do with this particular row and with this column, right? Good. Now to the last one, which is what? 2, which should be A24, right? Good. So which is 2, and then the sign there is positive, so we have positive value here, right? Good. So we are now eliminating this column, and then this row remains eliminated, right? So we are having something like what? 1, 2, 3, which is what? 1, 2, 3. Then the next thing is what? 2, 4, 3, which is what? 2, 4, 3. Then we have 1, 1, 1. So if you follow through as we have actually extracted the cofactor for each of these elements, you are going to have, or you should be able to arrive at what? These values, right? Good. So please take your time, try to pause the video, and then see if you can arrive at the same values as we have gotten for the other for the matrices, or let's say for the cofactors of the other elements, right? Good. Now we need to find the determinant of each cofactor. Remember that we are having 3 by 3 matrices. Yeah, good. Now, and we told that these matrices are actually in a bigger matrix, right? Good. So we are now going to find the determinant of each of these matrices, and the determinant we are going to find will now help us determine, or will now be the elements of our cofactor matrix. Are we together? So we are now having a value here, another value here, another value here, another value here. So we'll be having 1, 2, 3, 4. We'll be having a 4 by 4 matrix because we're having 4 rows and what, 4 columns, right? Good. So by the time you find the determinant of this matrix, you get a value. If you find the determinant of this, you get a value. The same thing for this, down to what, to this last let's say element, right? Good. Because each of the elements are now represented by a matrix. So now we need to find the determinant of each cofactor. Remember the explanations earlier. You can rewind the video for clarity, right? Good. You can always pause and rewind. Now, 3 by 3 matrices are simple to calculate or to manipulate, unlike the 4 by 4 matrix we started with. So immediately you get to this 3 by 3 matrix, which is something like this. It's always easier. You just follow through as for what we explained there, right? So you pick the first element, you form a 2 by 2 matrix out of it. You pick the second element, you change the signs. Please pay attention to that. You alternate the signs. So we have plus, minus, plus, right? Good. You alternate the signs. Then you now get what, the determinant. You do the same for this, the same for this, the same for this, as we have explained on this other part, right? Good. If you have done all of these things right, you should be able to arrive at a matrix like this. Good. So a matrix of the cofactors determinants, good. A matrix of the cofactors determinants will be something like this, which means for the first A11, you should be able to arrive at -1. For the A12, -1. For the A13, 0. For the A14, what will be 2. So if you have done all of the determinant calculation for each of these smaller matrices, all of these smaller matrices, right, you should be able to arrive at what we have here, right? Good. So this will now be our cofactor matrix. Recall that the adjoint of a matrix is the transpose of the cofactor matrix, and we are using what, adjoint method, as it was given in the question. We are using adjoint method to try to find the values of what, of our unknowns, right? Good. So the adjoint of a matrix is the transpose of the cofactor matrix, which means C transpose is equal to what, adjoint, and we already have C. So for us to have the adjoint, it's simply what, to transpose this, and to transpose simply means changing rows to columns, right? Good. So this particular row will be changed to column. This next row will be changed to column. This other row will be changed to column, and then the final row 4 will be changed to what, to column. So it's very simple. So by the time you turn this, I think it's in 90 degrees or 180. By the time you turn this down, you have what, this your row 1 becomes your column 1, as you can see we've written here. So we have -1, -1, 0, 2. Instead of going from left to right, it's now going from what, top to bottom, which defines what, row, right? Which defines a column rather, right? Good. It was a row here, it's now a column here. So we come down to the second row, which is 2, 2, -1, 3. It's now what, a column here, right? Good. So we come to the next row, which is what, -1, -2, 1 and 2. It's now what, a column here, right? Good. Then we have what, 0, 3, -1, sorry, yeah, 0, 3, -1, -3, which is now what, the next column. Therefore, this is what the matrix of what, of our adjoint. Again, recall the expression we've stated earlier, that your x, which is the matrix of the unknown, is actually what, equal to the inverse of A multiplied by B. Then the inverse of A is actually equal to what, the adjoint of A divided by what, the determinant of A. Now in this expression, we already know what our adjoint is, which is this last expression, and then which is this last matrix rather, and then we also know what our determinant is, what, which is what, -1, as we have what, as we have gotten earlier, right? Good. So what we are now going to do is that we are going to add, we are going to just fill it into the equation, which now means that for our inverse we have something like this, 1 over -1. Now the reason why we have 1 over -1 is because the determinant is -1, and from this expression you have what, adjoint over the determinant. So if you are trying to make the determinant, or the determinant is actually the inverse rather, is actually the adjoint multiplied by 1 over the inverse. Remember in mathematics, if you have 1 over A multiplied by B, you can actually have it as what, B over A. So instead of having it as we should have just written that out, please just write that out. So this can still be written as what? 1 over the inverse, sorry, 1 over the determinant multiplied by the adjoint. Are we together? 1 over the determinant, which is a determinant of A, multiplied by the adjoint. Because 1 multiplied by any number is still that number. So it's still the same thing as what? The adjoint over the determinant. So in simplification, we now have what? 1 over the determinant, which is multiplied by, which is minus 1 rather, then multiplied by what? The adjoint, which we have just computed earlier, right? Good. So when you simplify through, minus 1, so 1 multiplied by anything is still that number as we stated earlier. So minus 1 times 1 will give you minus 1. So minus 1 over minus 1 will give you 1. So 2 over minus 1 will give you minus 2. Minus 1 divided by minus 1 will give you 1. Then 0 divided by minus 1 gives you 0. So that's how these elements change, right? Good. Coming down to the second row, we have minus 1 divided by minus 1, which will give you what? 1. 2 divided by minus 1, minus 2. Minus 2 divided by minus 1, which is 2. Then 3 divided by minus 1, which is what? Minus 3. Going further, we have 0 divided by minus 1, 0. Minus 1 divided by minus 1, 1. 1 divided by minus 1, minus 1. Then minus 1 divided by minus 1, which is what? 1, right? So finally, we have something like 2 divided by minus 1, which is minus 2. Minus 3 divided by minus 1, which is 3. Then 2 divided by minus 1, minus 2. Then minus 3 divided by what? Minus 1, which is what? 3. Are we together? So this matrix you can see here is actually the inverse of our A matrix. Are we together? This matrix here, this 4 by 4 matrix, is what? The inverse of our A matrix. Finally, because this is the end, finally the X, which we have expressed here to be the inverse multiplied by B, we now have our inverse, and we know our B, right? From the beginning, we told you that the B matrix is actually the matrix of the constant, right? Good. So finally, we can now multiply these two matrices together. So you remember how we multiply matrices? Row by column, row by column, row by column, row by column. So if you have done these things right, which is what? 1 times 2 minus 2 times 1, 1 times 5, then 0 times 2, you get some answers, right? Good. So you have 1 times 2 minus 2 times 1, 2 times 5 minus 3 times. So if you have done these matrix multiplications correctly, and good, we also have videos on the channel where we've shown you how to carry out a matrix multiplication. So the links to that video or the link to that video will be on the description section, so you can check it out. If you have done this thing correctly, you should be able to arrive at what? This particular matrix, right? So we have what? 5, 4, minus 2, 1, right? Good. So this will now represent the values of each of the unknowns. So we have what? A, B, C, D, which means that our A is equal to 5, our B is equal to 4, our C is equal to minus 2, and then our D is equal to what? Minus 5, right? Good. So if you've done this right, you should be able to arrive at this value. Please confirm these values. Please confirm these values. Now we are going to check using equation 4. And according to equation 4, we have something like what? A plus B plus C plus D equals to 2, right? Good. So checking using equation 4, which is what? A plus B plus C plus D equals to 2. It now implies that we have 5 plus 4 minus 2 minus 5. And that will give you 2, which means the left hand side is equal to the right hand side, and that's what is checked, and it's okay. So these are the values of what? Of our unknown. So you can now use these values to check for the other what? For the other equations, or let's say for any of the other equations we have in the system of equations, right? Good. So we hope that, or we believe that we've been able to show you how to get the unknowns, the unknowns from a system of equation when there are 4. So a system of equations with 4 unknowns, right? Good, using adjoint method. So we've actually seen a lot of things: cofactor matrix, adjoint, inverse, and so many other stuff. So thanks for coming to class. We are going to see you on our subsequent video. Until then, keep being good at being a good mathematician, being a good spatial analyst, because we have that's actually foundation mathematics. So we are going to see you very soon. Until then, keep staying safe and have a very good time. Bye.